In this example, we're going to take the first partial derivatives of our function, where w is equal to the natural log of x plus 2y plus 3z. All right, so when we look at this, we notice that we have the variables x, y, and z. So those are the three things that we are going to take the derivative with respect to. Let's start off with partial derivative with respect to x. And I'll just write it out with respect to x of our equation here, plus 2y plus 3z. So in this case, what we're going to do is we are going to treat our other variables, our y and z in this case, just as constants. So we're going to fix them, and we're only going to focus on x. When we take the derivative of natural log of something, the derivative is 1 over that something. So 1 plus 2y plus 3z. Technically, because the stuff on the inside here is more than just a plain old x, we should be multiplying, we should be using the chain rule, so you want the derivative of the inside. But the derivative of this with respect to x of our inside stuff is just x. So we're just multiplying by 1, which means that here is our first partial derivative. We're done with that. Second partial derivative is going to be with respect to y. And I'll write that out again. It's kind of nice to have our equation in here so that we can refer back to it as we are taking our derivative. All right, now we are going to take the derivative with respect to y here. So we are going to have 1 over, same as we had before, 2y plus 3z. But now we're using the chain rule, which means that right up here, we have to take the derivative of the inside with respect to y, and the derivative of 2y plus whatever. And remember that x and 3z, those are all just treated as constants. Derivative of 2y would be 2. So we're going to multiply that by 2. And if you want to make that pretty, you could just write it as 2 divided by 2, x plus 2y plus 3z. So there's our second derivative. Third one is going to be pretty much exactly the same. By now, you see the pattern. So we're taking the derivative with respect to z, x plus 2y plus 3z. So derivative natural log of anything is 1 over that anything. And then we take the derivative with respect to that inside junk. The x and the 2y are treated as constants, so they're going to disappear. And the derivative of our 3z is going to be 3. So we're multiplying by 3. And again, if you want to make it pretty, we can just write as 3 divided by x plus 2y plus 3z. And there is our third partial derivative. Thanks for listening.